temperature decreases, delta U becomes negative. And this already I told you in the last class that work done will be positive in case of expansion, and in case of compression, work done will be negative. Okay, we'll discuss the questions. You first write down the first law of thermodynamics. Okay, zeroth law we've already done. This is the first.
Yes, ma'am. Yeah, ma'am.
Okay, look at this question. This says that 1 gram of water at 100 degrees Celsius is converted into steam. Now, if the volume of steam is 1671 centimeter cube, you have to find the change in internal energy of the system. So, see, for finding out the change in internal energy, the formula is, look, the formula here that we write is delta Q is equal to delta U plus the work done. Now, what all things are given? For delta Q, what can we do? L is given. So how do we calculate the heat when latent heat is given? Yes, Aleena, say.
Yes, ma'am.
How will we calculate delta Q when L is given? Mass into L, ml. Okay.
Yes, ma'am.
Mass into whatever is the latent heat given. So here the mass that it is given is 1. Latent heat is 2256. So 2256 joules will be delta Q. What are the other things given? If 1 gram of water at 100 degree, okay, volume is also given to us. So we can calculate the work done. So 1 gram of water at 100 degrees Celsius is converted into steam. Volume of steam is given as 1671 centimeter cube. So here this will be P delta V. Pressure is 1. This is 1671 joules. So what your delta U would be equal to? Delta U will be equal to delta Q minus,
Minus delta work done.
right. So 2256 minus 1671. This you can take out whatever is the value. You also tell me this much of joules. Okay. Write
Yes.
it.
And ma'am.
Okay, coming to the second law of thermodynamics. So second law basically says that heat flows from the system which has the lower value of temperature from the lesser temperature, okay, from the lesser value of temperature to the greater value of temperature. This moves, okay, lesser value of temperature to the greater value of temperature. All right, this is how it moves, okay. Now, heat energy will flow from this to this till when? Till the state of thermal equilibrium is achieved. Right? The condition is that without addition of any energy. Basically, the heat will only be flowing. So from where it will flow? From a cold body to a hot body. So whichever has a lower value of temperature, it will flow to the higher value of temperature. Okay, so second law of thermodynamics says heat flows naturally from a hot body to a cold body. Heat will never flow itself. Okay, heat will never of itself flow from a cold to a hot body. Always it will move from lower to higher. That's why you see, if you have a very hot kettle present and you have a colder one present and you bring them in contact with each other, what will happen after time? The colder one will also become hot. This processes we have seen also convection, conduction, and all. So there is one more topic which is called as the entropy. Now, entropy is not specifically there in your syllabus. You should know that. What is the state of entropy? Entropy basically means randomness or disorderliness of system. When I say randomness or disorderliness, it means this is a chamber and all the molecules are present in a random manner. There is no organized fashion like this. Randomly, the molecules are placed anywhere. So this randomness of molecules or the ability which they can move here and there. This is called as the entropy or the randomness. So formula is the whatever is the heat divided by temperature. So heat divided by temperature. You increase the temperature. Okay, this is not time, this is temperature. You increase the temperature, the entropy will decrease. Okay, and you decrease the temperature, entropy will increase because entropy is inversely proportional to temperature. So this is the second law of thermodynamics, that the heat will flow from a hot body to a cold body and make the cold body also warm. Fine, did you understand? It's very simple one.
Yes, ma'am.
Yeah, write this also.
None, ma'am.
Okay, so some of this we have already discussed. Now, what are the thermodynamic parameters? It is a thermodynamic system is what? It is an assembly of extremely large number of particles, like your atoms and molecules, having certain pressure, volume, and temperature. So these are the three parameters on which we have to do our study: pressure, volume, and temperature. Now, two kinds of system exist: isolated system and a closed system. Now, in isolated system, an isolated thermodynamic system is one in which no heat can enter or leave the system. Means when you're talking about the isolated system, the net force becomes zero and the wall becomes adiabatic. Here in the wall becomes adiabatic. Now, what is a closed system? An isolated system, this is a closed thermodynamic system is one in which heat can enter or leave the system. Thermodynamics V is equal to N0. Write it. Is it audible now, Aleena?
Yes, ma'am.
Okay, did you hear this? What I was saying?
No, ma'am.
See, I said that in an isolated system, net force is zero, which is used in adiabatic. We'll see that. And a closed system in which the heat cannot, heat can be entered or it can exit with the system. State variables or thermodynamic states, these are the pressure, volume, and temperatures. So equation that connects these is this: PV is equal to nRT. So write down this, then we'll see one last question from first law of thermodynamics.
Okay, ma'am. Done, ma'am.
Okay, look at this question. This says that find the change in internal energy of a system if 415 calories of heat is given to the system. Okay. Uh, and the system does 35 calories of work. So if we are calculating the heat, it is 415 calories. And the work done is given as 35 calories. So if you see, we have to calculate delta U's value. Now, this is saying change in internal energy if heat is given to the system and system is doing work. If you remember, we started the class with this. When the system does work, okay, see, heat is given to the system, means heat is getting absorbed by it. So it is positive. And the system is doing work, okay, it is conducting work, right? So that will also be positive. So when you will apply delta Q is equal to delta U plus work done. So from here, delta U can be written as delta Q minus work done. So this is again 415 minus 30. Yes, okay.
Yes, ma'am.
Write it, see the processes.
Done, ma'am.
See, there are four thermodynamic processes that occur. So we have seen the four variables, also the thermodynamical state. So if one of them becomes constant, then we refer to it as the thermodynamic process. Like the first one is isothermal process. So here in isothermal, the temperature remains constant. Okay, there is no change in the temperature. Means change temperature is zero. Whatever is the initial temperature is equal to final temperature. Then you have isobaric process. Here the pressure remains constant. Means whatever is the change in pressure is zero. Initial pressure is equal to final pressure. In isochoric, we say volume remains constant. That is, change in volume becomes zero. So initial volume becomes equal to the final volume. And then we have the adiabatic process. No heat or leaves the system. So change in heat is zero. Whatever is the initial heat is equal to the final heat. Now, what's a non-cyclic process? We have already discussed that. A non-cyclic process is one in which the system does not return to its initial position like this. If this is the initial point, this will be the final point. Cyclic is one in which it returns. So these are the various thermodynamical processes. Okay, see, coming to the work done, how were we using the formula P delta V? So this is the piston, this is the force that occurs. So if I write the formula of work done becomes force into displacement. Now, what is the formula of pressure, Aleena?
Ma'am, can you repeat?
Formula of pressure.
Half mv square.
How much? Pressure is equal to force by area. So force will be equal to pressure into area. So work done is pressure into area into x. See, area into the length. This is the volume. So work done becomes P delta V. This is the derivation of it. These things you've already written the sign convention. So no need to write this part. This you've already done. Write it till here. Okay, Aleena, we'll complete it in the next class. Are you available tomorrow at 7 p.m. IST? 1 hour class I wanted to take. I'll not take it on 14th. So instead of 14th, are you there tomorrow? 7 IST, 7 p.m. IST?
Wait, let me calculate for my time.